Walden, who will be talking about the steps needed to install renewable energy systems. So renewable energy systems from inquiry to reality. Next, we have a demonstration by the Virgin Islands Energy Office on Friday, and they will be talking about their solar savings calculator, which may also be mentioned a bit during today's webinar. Next week, Wednesday, then we will be continuing with Powering Through a Blackout. This is a continuation of the flyer that we have put out with the CGTC. And it talks about different small scale small scale devices that you can put throughout your home to help when the lights go out. The next week on Monday, we will have a panel discussion with Martin Ford, an energy consultant from Rocky Mountain Institute, Kyle Fleming, the director of the VI Energy Office, and Doug White, a green architect from the Virgin Islands. And they will be talking about their different perspectives on the renewable energy transition in the Caribbean and in the Virgin Islands. And finally, on Thursday, October 29th, the Hazard Mitigation and Resilience Plan team and Keep Safe Enterprise, a group from Puerto Rico, will be talking about household energy and water resilience. So they have the Keep Safe group have created a guide following Hurricane Maria in Puerto Rico to give people kind of a easy to understand way of accessing this information about how to strengthen your home and prepare for and mitigate against disasters and surprises. So that's kind of what we have in store for this month. Before we get started with today's webinar, then I just wanted to go through some housekeeping rules. So in this webinar, then the host, we cannot see or hear you. You can ask us questions by clicking on the Q&A button, and you should specify if this is a clarifying question or a general question. If it's clarifying, we'll try to get to it right away, or else we'll have a Q&A session at the end. Feel free to chat and post comments in the chat room here, and we will mainly answer questions put it in the Q&A. Also, if during the Q&A session, if you'd like to ask a question out loud, you can raise your hand and we can unmute you so that you can participate in the discussion. And just a reminder to please be respectful. So now I'm going to hand it off. So I'll stop sharing my screen and allow Brian to share with you guys.
Good morning, everyone. My name is Brian Walden. I'm the Director of Operations for Pro Solar Systems Caribbean. And we are a full service energy or engineering, procurement, and construction company based out of the U.S. Virgin Islands with offices in Florida and St. Martin. And we were in the BVI until their most recent policy change, which was not as supportive. Surprisingly, in the Virgin Islands, we're looked at as kind of the progressives in the energy space, surprisingly. I say that because a lot of times it's felt that solar implementation is in its infancy in the territory. But from some of the names that Ariel just mentioned, you can see that it's definitely been alive and well and thriving. But we're seeing an industry-wide change. And within that, because of the hurricanes principally, and I'll talk about this a little bit further on later, we've been put into the forefront of what solar and storage can provide a community. And so we occupy a unique position where we're on the cutting edge of this technology. And through this most recent program, the net billing program, everyone will have accessibility to this. And it's something that we've been trying to see. When do you reach that cost parity when we start to look at this as an investment and be able to buy and use your own energy as opposed to having to outsource it? And then what programs with the utility can we integrate with in order to promote the utility's health as well as access to distributed generation resources? So I'm going to start off with a let's see, this should be.
How do solar panels work? You may have seen solar panels on rooftops in your neighborhood.
We're not seeing, we just see your Zoom screen, Brian. I don't know if that's what you wanted to share.
Sorry, what was that?
We just see a Zoom website.
Okay.
I'm not sure that if that's what you wanted to share.
And reprioritize.
Good afternoon, everyone. My name is Greg.
There we go. Screen share, desktop 2. Here we go. How's that showing up now?
Yes.
Okay.
How do solar panels work? You may have seen solar panels on rooftops in the neighborhood, but do you know how they actually work? Solar panels are made up of an element called silicon. When sunlight hits a solar panel, electrons
And don't
in the
worry,
silicon
this is fairly short.
move, initiating a flow of electricity. This is direct current, or DC electricity. Direct current electricity power most appliances in your home. Solar power is electricity
So we don't hear the sound, just to let you know.
Okay.
installers near you.
So Greg, you saying you can't hear that?
No, we cannot hear it very well.
It's not coming up. Let's see here. All right, well, we will then cut to the chase. Much easier. Hopefully everybody's already got a fairly broad understanding. That was a little bit of a remedial. That was really to try and get everyone up to speed a little bit about what the basic performance or functionality is of solar. Obviously, we've got solar panels on the roof. We've got a solar generation resource. It generates in DC. We need to convert that into alternating current or AC, which is used in the house. Traditionally, in the event of an outage, your solar array is on your roof. You have the capacity to generate electricity, but it does not have any AC connected to it. So therefore it just sits there. It's just ornamental because it has no way to store it. And there's no way, you don't want to accidentally send electricity back upstream where it becomes a hazard to others. So the latest innovation, obviously, to overcome this, and this is something that this new program actually incentivizes, is an ability for everything to sit on the common AC bus side. So we have solar generation. If you don't use that generation right then, right there, you go ahead and you put that into a storage device. That storage device in our instance is a Tesla Powerwall 2. So we put solar panels on the roof or a ground mount, we generate, we turn that into alternating current. That also works with a solar storage solution. So if you're not using it, it goes into there for nighttime consumption. And then during the day, and this is the part, this is the secret sauce. This used to be an entirely DC function with a relay switch you'd have to go and throw, or an entirely.
So Brian, what is DC and AC?
So DC is direct current. Direct current is what you get from a storage device or from solar panels, and it's incompatible with all the alternating current, which is what we use in our homes and in businesses. That alternating current has a supply and return within the same conductor, and it transmits over much greater distances and reduces wire size, etc. Alternating current is the much more functional use of electricity as opposed to direct current, which is a constant continuous flow of electrons in one direction.
So how does the current from the panel becomes AC?
How does the current from the panel goes into an inverter, and the inverter then releases that as alternating current, and that's the function of the inverter. Whether that inverter be located within the house itself or located under a panel on the roof, which would be a micro.
So you have your panels on the roof, that those wires go into an inverter, and that makes your current go from DC to AC, and you can use that current. Is that what you're saying?
Correct. Correct.
Okay.
Correct.
And so can you then remind us where you were then when you were talking about the new net metering program? How does that change from the past?
Okay, well, before I go into what the net billing program is and the change from the net metering previously to the current, you need to have solar now with storage is partially the premise. Now you can use solar to then return back to the utility. It's in a use it or lose it scenario. If you're consuming more than your solar production, then obviously you won't have anything to return to the utility and you'll still be pulling from some of the utility. But how does it prioritize? How does the house know? Well, basically that's what you see in this consumption hierarchy in a grid connected. The house is pulling first from the solar generation, second from the storage in a self-consumption mode, and third from the utility. And this is all happening on a single input into the home. It's automatically prioritizing this consumption profile so that if you're generating from the roof and the home needs that load, it is taking that energy immediately. Then if you exceed the output of that solar generation on the roof, it's taking from your storage. It's taking from whatever battery configuration you have. And then lastly, if you've 100% got your storage all the way up to the top, you're satisfying all of the loads in the house, it can return it to the utility. In the new net billing program, it can, or in the event of an oversupply or more than the storage and the solar generation can actually supply, it will pull from the utility, but it will always prioritize. So you're always getting a savings on your consumption. You're always prioritizing your alternative resource first, even sitting on the same grid, even sitting there with WAPA online simultaneously. Now, Greg, you had talked about we take the old program for net metering was a 1-to-1. And it was traditionally without storage. And generally speaking, without storage, the idea was to design a system big enough so that it would net zero your home. And net zero meaning that you would produce enough electricity from your solar array during the daytime to equal the amount of consumption that you had every day. Well, how do you determine what's the best system size for my home? How do I get to that point? And the easiest way to do that, and if anybody has a chance, take a screen grab of this or take a picture of it with your phone. This is how you can do an ad hoc system sizing. If you know your WAPA bill, I can show you very quickly how you immediately figure out what size system do I need. And we're going to walk through it real quickly because there's a couple of considerations in here that go into that AC to DC because there's a D rate. You have to take some of this production out. The industry always looks at system size or solar array size in DC. So in that conversion from DC to AC, there's some adjustment you need to make. First off, if your WAPA bill is $500 a month and you divide that by the cost of your kilowatt, which is 43, I think we've gone down a little bit to actually 42 now, that gives you 1,162 kilowatt hours a month. And we round that up to, since it's close enough, to 1163. Now you divide that by the average days in a month. The average days in a month, this would say if this was 30.4 for, this is your total kilowatt hours you consumed in the month. So there's your bill. You take the cost per kilowatt, divide it in. This gives you your total kilowatt hours per month. You divide that by the days available in the month. And this is what you need to generate per day to satisfy 100% of your load. Well, the sun's not up 24 hours, obviously. So a couple of things you have to do. Number one, we've got to add back in a little loss of system conversion size because we're going to end up coming out in DC. So we're going to multiply our 38.25 with a little 20% increase in here to give us 45.9 kilowatt hours. So I need to come up with a system that will generate that amount of kilowatt hours per day with the available solar window. Our
and
average,
the reason for that increase is because, like you said, there's some losses that happen when you go from what's produced in a solar panel to what you have available at your inverter. Is that correct?
Correct, correct. So the kilowatt hours per day divided by your available solar window. So you have 5 3/4 hours a day. This tells me my system size. And that's a good generic way that you can always run. And the other piece that's kind of interesting about this is I'm showing you the long-winded way. There's another way you can do this, and that's by going to the PV Watts calculator. If you look up here, you'll see the words NREL, the National Renewable Energy Labs. This is a free resource. Basically, you go into this, and we figured out our system size already. We did our little bit of our homework, or we can just go in here and fill out these fields, and we can start to work on what size system. And this is a free available resource from the National Renewable Energy Labs. Anyone can go on here, and you can find ways to come up with metrics to examine, and it'll run through these options for you. So we had 7.98 previously. We're going to say this is a premium panel because we only use premium panel. Here's those system losses I was referring to. 4 and 12 pitch, most common pitch is 18 degrees, and we're going to have this pointed due south. Now, one of the things is we've already said that everyone already has a working knowledge of solar. We always like to have these tilted at or about our latitude at 18 degrees to the south because we're in the northern hemisphere. So we need to have them oriented a little south. Generally speaking, majority of homes that have a 4 and 12 pitch, it's going to be 18 degrees. We'd like to use 180, but you only have a small D rate. We have an abundance of resource. We have a tremendous amount of solar capacity. So as long as you put them on a lower pitch, meaning I don't like to go over 18 degrees, you can orient these to the east, to the west, and in some cases to the north. You have to be careful with the northern projection, but if you have a flat roof that gets good solar exposure and it's tilted and it's facing north, if it's only got a few inches of drop, you're still going to get very reputable output. But if you're curious about it, all you have to do is go in here and actually take the time to fill this out a few times, change the orientation. This allows you to change the orientation, and it allows you to set up the rate for your kilowatt hours, et cetera, and run through a different scenario. So we're going to say it's 180.
So, Brian, can you remind us why tilt and azimuth are so important? Can you remind us why tilt and azimuth are so important? Why does it matter?
So the tilt and the azimuth matter in that you're trying to expose the plane of the solar module because that's the generation resource. And we would like to have that have as much solar exposure as possible. So we're trying to find the most commonly plane that is going to match the arc of the sun to the greatest extent so that we get the greatest solar exposure so that when the energy hits the surface of the silicon and the electrons start to spin off, we've got the greatest output possible.
And right now, 18 degrees and 100 degrees for the azimuth are what's best for the VI?
I would say that I love this. I would say that you want to have a minimum of 7 to 10 degrees just to shed water so water doesn't pond. Optimal would be 18 degrees without tracking. But again, with an abundance of resource, as long as you've got enough water, enough pitch to shed water, you're still going to get very advantageous output. So once we kind of run in our system here, and looks like it's kicking it back, but or maybe it just refreshed from when I was last in this. 0.43. And voila. So we put in the cost metric. It tells us here's your solar radiation per day. Again, queuing back to what Greg was talking about, having the orientation where it's got a good pitch. And you can see through the course of the year, and obviously right now, we're starting to diminish. Again, with solar, you're looking for the overall output for the year. You're looking for the average. So we're looking at the annual output here. We're not looking at a specifically low number because we're going into a lower solar exposure. So we're looking at that. So
and solar radiation is the amount of energy that comes directly from the sun.
correct.
That has nothing to do with what you can capture.
Correct. It's what's available. So if there's cloud cover, there's going to be less capacity. All right. So we've gone over real quick about how the systems currently have a different operational capacity. You've got traditional solar that sits on your roof and it generates, and you have a use it or lose it scenario. But it's the easiest access point. Then the second piece, that's the newer piece, is you have solar and storage. If you don't use it, you put it in a storage device and you use it at night. And this also sits simultaneously in line with the utility so that it's interactive under the net billing program, or you can take it off grid and be completely. In the event of an outage, if you have storage, you can have a relay open just like an automatic transfer switch and be completely islanded. And you can be completely on your own. And you've heard the term microgrid thrown around, and you basically have formed your own microgrid. And it was after Hurricanes Irma and Maria that we saw the huge need, the huge outcry for people that needed some type of alternative generation where they weren't burning diesel fuel on a continuous basis. So the resiliency component of solar comes into play. And a lot of people talk about, all right, I've determined what I want. I've determined the system size I need. I've checked it with some of this information. I feel like I've got a good grasp of it. You know, well, what program you keep talking about do I have to take a look at this? And obviously the Virgin Islands Energy Office, and I'm going to touch on this fairly quickly. And then obviously what I'd like to break this down is when we get into the Q&A, and also allow the Energy Office representatives to be able to back this up again, because there's a lot of info here and I'm not going to hit it all by any means in this one session. So I want you to have the ability to kind of hear an overview of it and then maybe formulate some questions or some practicality for your own situation. And obviously you can contact me or you can contact the Energy Office, but you'll also have another chance to interact with the Energy Office on Friday. And I definitely want you to take the opportunity to discuss with Kyle and his colleagues exactly the nature of this program, because it's imperative that this program be successful. This is the avenue. This is the application process. This is the access point that we all have now in order to implement solar. Everything was gray previously. So one of the things I invite you to do is go to the Virgin Islands Energy Office website. If you just type in Virgin Islands Energy Office, it's going to throw you to property and procurement, and it's not accurate. It's an older website. So definitely look for vi.energy.vi, and I know that it'll pop up if you start to look. I basically, as soon as it pops up in my Google search, it'll say website. So it's, you know, I'm going through that a little more quickly. I'm not giving you the accurate Energy Office website. But needless to say, once you find the Virgin Islands Energy Office website, go ahead and run this up real quick.
So it's, I believe it's energy.vi.gov.
Energy.vi.gov. And really slow response here.
So while we wait, Brian, can you answer this question? Should we always shoot for 100% of our needs when we do the sort of calculate, you know, how much solar we should have on our house?
So always remember that if you put even a small amount of solar on your home, just in a generation capacity, you will gain the benefit of it. It will always be worthwhile to offset some of your consumption and be able to create some of your own energy. Whether you use it at the moment or return it to the grid, there's always a net gain in that capacity. And you don't have to offset 100% of your energy. You just need to be able to satisfy your needs and your goals. If you're home during the daytime, which a lot of us are now, or we're home more than we were, because of isolation. If you're generating electricity in the daytime and that energy is going directly to your home first, you're getting the net billing effect of it without it going back to the grid. So you're getting the retail value of that electricity, and that's beneficial. So you're getting a return on your investment. A lot of the salespeople like to refer to, do you want to rent your electricity or do you want to own your electricity? You can own it now. If you go to the Virgin Islands Energy Office website, as Ariel mentioned, it basically, this is really strongly structured around the net billing program. And the net billing program, I really invite everyone to go on. I'm going to kind of jump forward here a little bit. You'll see it right here, view program overview. This is a great breakdown. Everything is in here, from how the program works, what functionality it has, how you permit additional fees, the fee structures that go with it, the why, and then there's another piece in here that we'll take a look at momentarily, which is actually the savings calculator. And that is unique. And the one thing that is also unique that separates this from the old net metering program is that everything's online now. The flow chart on the old program was problematic functionality wise. It took a long time for it to navigate back and forth between 3 or 4 programs. Right now, it's definitely starting to become a little bit more streamlined. Now, let me explain some of the aspects of this program so that we can distinguish, Greg, between the old program and the new program. The intent of this program is to be transitional. Note the word transitional. Distributed generation market structure that provides access to energy saving benefits to grid connected customers. So it says it right there. We're trying to key towards those that are going to stay interconnected to the grid, and that's principally it. And it's a transitional structure. So one of the things that hopefully Kyle can, or Mr. Director Fleming can address on Friday is that, what's the next one? This program has been enacted and approved and is the policy. And I've heard from WAPA representatives that the consideration is that even if there is a subsequent program to this, that if you prefer to stay in this program, you will be allowed to stay in this program. Now, anyone who is currently watching this and has the original program, net metering expires in 2025. It was passed by the legislature a good while back, so it is, I invite you to look at the code. It was part of the feed-in tariff discussion with Senator Barsinger a few years back, if anybody's been around since then. So here's the way it works. You go in through the portal, you apply, you get everything going forward. Obviously, you work with a solar energy provider, which would be ProSolar, of course. And then we would submit your application and design packet, permit packet, everything needed. Now, one of the things that I noted on this discussion was that we talked about the do's and don'ts or best practices, and we'll discuss some of that more in the Q&A session. So if you have a system at your home, and remember we were talking about system sizing, you're going to be charged a grid access fee. So we're going to pay for a permitting fee, and then there's going to be a monthly baked in fee to have access to the grid. So this is where it incentivizes storage, because now you're always getting the retail value of that electricity, because you're either using it at that moment at retail rate or putting it into a storage device, using it later, valued at the retail rate. And that's the distinguishing characteristic. But all of this can be done simultaneously, because again, we all sit now on the common AC bus, which is the 3 points are there: solar, Powerwall, WAPA. It will now use a hierarchy: take from the solar first, take from the storage second, take from the utility third. In order to have access to that third leg, they're going to charge a small fee. That fee is to cover maintenance, infrastructure, lines, and other pieces of that nature. And if it's under 6 kW, that flat rate fee is going to be $20. 6 to 9, 35, 9 to 12, 50. And then they're going to kind of flat rate it, where if you start to go larger, The majority of the homes that we as a solar contractor have installed is around 10 kW. So we're creeping up on the high end of the grid access fee simplified permitting process. But they do denote within the description here of what that grid access charge is going to be. And it does not need the additional supplemental reviews until we start to get into these really large numbers, which you very seldom will see anything over about 100 kW because of the previous policy structures. So, you know, right now, fantastic. You can reduce your bill. There's a calculator that shows you exactly how much it is. There's solar contractors ready to do the installation, and we have financing now. So one of the things that also changes about this program is that if you do put energy back into the grid, it is no longer going to be a retail to retail rate. You get a reduced allowance for that billing or that net push back into the grid. And that is going to be 75% of the LEAC. And that 75% of the LEAC right now is about 12.5 cents a kilowatt hour. 12.5 cents a kilowatt hour is still above the stateside average per kilowatt hour. So it's not, it doesn't sound as lucrative as the previous one, but obviously it is a realistic amount to provide as a return for pushing electricity back into the grid. If you do so and you develop a credit based on that cost structure, at the end of the month, that credit goes back to zero. It stops every month. So if you don't live on island and you have a system that generates like crazy and then it pushes back and it zeroes out your bill, they've eliminated that structure. It's not going to work anymore. You have to either use it or lose it, even in your credits. The permitting optimization is we're worked through some of the pieces, but the online payment structures now work. The online review structures are finally starting to push through. The WAPA hosting capacity aspect is starting to come through. All of these pieces are starting to come together. And one of the ways that you can use to kind of predetermine, because we've discussed solar, which we all understand that some of you already know all of this. We've discussed how the product works. We discussed the hierarchy. We've discussed how to check on those numbers. And then we talked about the local program. And now we talk about this. And this is the system sizing calculator. This is on the website, just down one from the program outline. And you'll also see the signage documents that are needed in an application process. And it basically puts you here to help you understand if you want to get at some analysis, and your solar provider can help you walk through this process. Or I'm sure that if you were maybe potentially reach out to the energy office, they might be amenable to helping you walk through some aspects of this. I would say as a solar provider, we're more than happy to help you walk through this to understand it. And it's a great tool. Now, this does not determine what cost is for the system, but it does allow you to do some unique features. Everything that I've spoken about previously is based on your consumption profile. Right here is the consumption profile of someone who is out all day at work. Through the evening, you wake up, you get this nice big spike in usage, it comes down, everybody's at work. Afternoon, maybe it's hotter in the day, maybe there's something cooling the house, maybe there's just a little higher energy draw. Then you get down here and you get into the end of the day, and here's that back end of the spike before you go into the evening where it starts to drop even more. We can change these profiles. You could do a small office, you could do all the way down to hotels. If you look at a small hotel, what's that look like? Blazing speed. Okay, so we saw things tick up. We get a little less spiky, a little higher consumption through the middle of the day. For all intents and purposes, we're going to kind of go back to the old school out all day. Because that is the traditional profile that the majority of consumers are using. I would say the majority of the people, with the exception of the recent COVID crisis, this is the traditional profile of someone who owns solar. This is a residential piece. You're in the customer class. So one of the pieces that we did previously, if you looked at that system sizing calculator for that, I showed you the manual process of how to do that. is what's your monthly electric bill? $500. Say $500. This goes through. You don't need to change all of these pieces. Really what you want to key on is $500. You want to match your usage profile. You want to match it with what your monthly cost is. And those are the two key ingredients. Once you have those two metrics input into this calculator, you don't need to worry about all this other information. These are calculation metrics that are not useful to the user. You don't need to change them. The orientation, again, we go back here to the orientation and we talked about the available solar exposure. If you're going to break it up, this is the spot to break it up. You may have one plane of the roof that has this exposure, and then you need to juxtapose it with another one. If you want just generic metrics, keep it south and move from there. We said $500 was our usage. We did a back of the envelope calculation to zero it out. All right, so I kind of figured out what a net zero configuration is under the old program where I could zero it out 100%. And that gave me a system size of 7.98. That's 7.98 kW. Now I'm going to run this into storage because I want to see what everything is with the storage. If I wanted to get rid of storage, I'd go down here and I'd just zero all this out. Remember it says battery system. In the solar, we want to put in the orientation. We want to put in the system size. And you see here it's DC. Industry standard. Solar arrays are always referred to in DC size, which is always a greater amount than the actual alternating current production because there's always a loss. Inverter losses, 4%, system losses, 14%. Don't need to touch any of those. Here's a degradation factor, D-rate over time. Don't need to worry about it. Now we get into the actual storage system.
Before we get into the storage, what are like the minimum requirements that somebody might need in their house to have solar on their roof?
Okay, so generally speaking, let's look at some parameters. So if you've got, under our current WAPA usage, 10 panels. 10 panels is 3.2 kW. So 10 panels, and each panel's 3.5 feet wide by 5.5 feet long. So if you just use 3 by 5 mentally, it gives you a better representation. Meter by meter and a half, if that's your thought process. And if you put 10 of those panels on, and 10 of those panels, those are 18 square feet apiece, right? 3 times 5. So if we've got 10 panels, that's 1,800 square feet, right? So, or 180 square feet. So if you got 180 square feet of roof, you can put 10 panels on. That's 3.25. And if you went back and used our calculator, you could see the specifics, but it's around $150 a month. So
but this is only the south-facing roof, or can you put it on all sides?
You can put it on south, number one choice. You can put it on east. You can put it on west. In this example here, because we talk it out all day at work, we're not going to have a lot of solar exposure here. So if we put it on the east face, where it's going to get the highest production curve the soonest, we still don't have a lot of solar exposure. We're still not going to really get solar until we get up into this range over here, more along this time metric of between 8 and 10. And in this usage profile, you see how we're declining. So you can always put it on east. You can always put it on west. My preference, and from my experience, you want south and west. South and west are your ideal. So in a descending order, I like to go south, I like to go west, and I like to go east. And then in some instances, because there's no other option and it has decent exposure, we'll go ahead and use north, as long as it's not on a severe pitch. The inverse for the opposite side of the roof is true when it comes to pitch. We want that on a really low pitch. We want to get as much solar exposure as we can. And the D rate on that can be about 30%. 30% off is not a lot when you put it on the north side. If you were to put it on the north side in a more northern latitude, you'd get nothing. So you can put them on any side, but in order of hierarchy, south, west, east, north as a position of last resort.
Thanks.
So once you put in the calculator piece here, and remember, if you don't like the result, or you're worried or you're confused that you did something wrong, just exit, go back to the website and reload it. It's not a problem. But you can see from this metric with storage, we can knock the bill down. This incorporates the grid access charge. This incorporates the base rate fee. You can knock 83% of your bill off and have backup power. And then we've got future structures where if we wanted to discharge back into the grid, we could. So you basically have created your own little energy storage system, your own energy generation system. And in the event of an extended outage, you'll have the capacity to run off-grid 100%. A lot of people like the idea of off-grid, but I want to tell everybody that I have a great resource for 90% of the time. There's still 10% of the year that even if you do a net zero system this large, it's gonna rain, or everybody's gonna be visiting in the house and using up. It's November, it's raining, and everybody's over for Thanksgiving. I know we've got a little reduced capacity in that regard, but it's still, what if it drains the system down? There may not be enough solar exposure the next day. All of this is predicated on all of this orange being available every day. And there's instances, at least 10% of the time, where it doesn't. And in that instance, you've either got to have a utility or a generator. Utility can be a very good resource for that.
So if you don't have a storage system, does that mean that when the power goes out, your solar doesn't work?
That's correct. That's correct. If you don't have backup storage in sorry, give me a minute here. If you don't have storage, your solar is a use it or lose it scenario. And one of the ways that we ensure that that happens, or the industry ensures, and this is part of the certification program, is that all of the power electronics in a solar system that convert it from DC to AC is powered by the grid. So as soon as the grid is gone, the inverter ceases production and you get no output. So in the event of an outage, when the grid goes down, the solar array goes down. The only way to get it to reactivate is to use a storage device that mimics the grid and allows everything to come back up. All right, let me go back to, I'll stop my share here. And
so we do have one question. I think it came up earlier on, and it was about what kind of policy change affected solar power in the British Virgin Islands?
Okay. The British Virgin Islands used to have a law that said you have to buy all of your electricity from BVIEC. And the only time you were allowed to have solar is if it was 100% separated from the grid in a stand-up scenario only. And in the older technology, that really limited people's access because it could only be done with generally older technology and lead acid batteries. And space is at a premium, and obviously cost was a consideration. They changed that law in 2015 to allow grid-tied solar with the eventuality of developing a regulatory process that would allow net metering of some fashion or net billing of some fashion. They rolled out the actual regulation in November of 2018, and when they rolled that out, it had basically a 2-meter setup that is more akin to what's known as a feed-in tariff. Basically, every kilowatt hour that was produced by that system, the BVIEC charged you 10 cents a kilowatt hour. And that 10 cents a kilowatt hour plus more complex structures that went into fuel surcharges and the other things, it complicated the issue. There was not a clear regulatory process. It may have gotten better, but basically that rolled out in November of 2018, and here we are 2020. And I would say there's probably been 3 or 4 systems installed in the BVI since then, maybe more, but It's unfortunate because they could interact with WAPA, surprisingly, I'm recommending this, and learn from the process and the net metering program, et cetera, that we've already gone through. You remember that net metering was passed in 2010? So there is some track record. We're actually moving forward. We're actually moving forward, and we're developing processes that other islands can emulate and learn from. And through extensions like the Green Technology Center at UVI, and workforce development programs like the ones we interact with the St. Croix Foundation, I need solar installers. I need solar designers. You know, this is an industry that's growing, and the U.S. Virgin Islands is uniquely poised. The director of the St. Croix Foundation says she has I shouldn't be speaking directly for her, but she would like it if we were a resource for the Greater Caribbean for solar energy specialists. And because of Irma and Maria, the Powerwall 2 had just come out. And just like the Tesla cars, it was a game changer. And that game changer, everybody is still trying to catch up to. But yet, utility is starting to understand there are 1,200 of these installed in the territory. And with this program rolling out and with access to finance, every government reconstruction, every bit of federal funding that's been earmarked for reconstruction has a solar component. When people look to invest or to buy in the Virgin Islands and in the Caribbean large, they are looking for solar, because not only do they want to reduce their operational overhead, they want that resiliency. 80% of our systems were up and running after the hurricanes. That's the type of longevity, and our systems are better now than they were then. We can't protect from impact damage. That's a given. But you can take resources that were like surviving the storm from Rocky Mountain Institute, the interaction with the Virgin Islands Energy Office, which now has a much more robust academic and technical resource department, or well, I shouldn't say department, but staffing. So, you know, there's lots of things that we are unique in the Virgin Islands to that we can build upon. And the technology is there, and it is running rapidly. And, you know, why not make it an industry? Why not make it accessible? People are very receptive. People are very receptive. So we're hoping to support that.
I think or the main message about that was kind of that policy change like really does impact the market as well, and that, you know, having the right policy systems in place here in the Virgin Islands can really help to accelerate this field.
Absolutely. Absolutely.
So I just want to add one more thing to what you were saying. Yes, it's very difficult to protect against impact when you have hurricanes. But there are also a lot of guidance coming out in order to ensure that the panels are, you know, safe and secure on your roof and cannot be blown away like, you know, happened to some houses after the hurricane. So there is a fair amount of guidance. There's a lot of knowledge. A lot of federal agencies and others have learned from the VI about, you know, how to really properly install solar panel in hurricane-prone areas. So to your point, they had a lot of resilience and robustness to the house level. One question though, going back to the basic of, you know, how do you sort of know, you know, what type of system you should have on your house? Does the type of roof that you have matter?
It does matter, and it matters in one way more than any other, which is the lifespan of that roof. If your roof is damaged or not properly secured, nearing the end of its useful life, there's no point in making a very large capital investment to put solar on top of that roof without investing in that being a properly installed, properly inspected, properly engineered roof. When we put solar on top, we're adding a little exoskeleton that will reinforce it. So the roof will be stronger after the solar than before the solar. But there's no point in making that type of investment and having to turn right around and take it off because it's leaking or what have you. You know, when we put things on a roof, we expect that to not have to be moved or expect any maintenance underneath it for 10 to 15 years. We're looking for a life cycle of 20 plus years. And that's what we're basing our performance or return metrics on as an investment. So, you know, it's critical that you also take steps to reduce your consumption. Huge gains in energy efficiency, replacing lights with LED. Although some might differ with me, I think it's worthwhile to consider using a gas dryer as opposed to an electric dryer, just because of the cost, and it's a high impact, high load item. It gives you greater autonomy, and that greater autonomy gives you greater resiliency. So it's nice to kind of incorporate some of those things. Don't get me wrong, I'm not going to say we need to burn more fossil fuels by any means, but
we can also use the sun to dry our clothes. We don't have to use a dryer.
We give away free solar dryers with every system. Yes.
Yes. So another follow-up question then, I guess a follow-up statement to what you're saying. So it means that if you want to install a solar system on your roof, maybe you want to check the age of the roof, the quality of your roof, but also check if your roof is up to code, because you don't want the roof to blow away with all your solar panel during a hurricane.
Right. If the new wind loads that for engineering are after Irma and Maria are extreme. Generally speaking, previously we used to use 155 to 165, and I recommend you talk with Doug White about this. He can be much more specific, I'm sure. But up on Skyline Drive, the wind maps are 240 mile an hour. So if you're looking to design a system and you're in that area, you need to be considerate of the topography, your location, and how to engineer that system. We sell 2-rail installation systems and 3-rail installation systems. The Rocky Mountain Institute says you should use a 3-rail system if you're in a high exposure area. It's a cost consideration, but it's something that you have to validate, you know, on an individual basis and make sure that it's attached properly to a resilient structure that's going to give you the life cycle to warrant that reinvestment. I see a couple of questions in here. Do you guys mind if I run through a few of these?
Yeah, just one question came in actually before the webinar, sent to my email, and I think it relates to what you were saying. It was, how often should the equipment be serviced?
So in the instance of a grid-tied system that is just a cost abatement structure, you want to keep them clean, and you really don't need to do much more service than that. The service really comes into the monitoring platforms. It used to be you just plugged in solar and you watched your meter spin backwards and you said, oh, look, it works. Well, now everything's based on having internet access and full visualization on every aspect of it. And basically, we get several phone calls a day from people who are, you know, looking at their app and you know, wanting to know what's going on with their system. So the service calls, as long as you keep the panels clean, every 5 years you should be checking for, you know, any conduit chafe, any grounding issues, not being properly grounded, you know, and integrity of the system, making sure there's no electrolysis or corrosion that indicates straight current. There's some other little pieces that you can do in order just to make sure that the system is performing properly. Now, when you add storage on, and this is something that whenever we go to seminars in the States or conferences in the States, people are just getting into storage, whereas we've been running at this full speed since the end of 2017. There's a service component. The service component is, if you look to replace the utility in some aspect, you have to offer the same functionality and support within 24 hours. And we're working on putting places or putting in place a service department to answer the majority of these needs. A lot of this can be satisfied over the phone or remote access, part of the wonders of the technological age, but it also creates almost as many issues, because if people can't see it because their internet went down, they assume it's not working. So it adds another layer. But anytime you come up with the idea of eliminating the utility and going off grid, there is a much higher service requirement needed. If it's just tied to your house, it's reducing your cost. Set it and forget it. Clean it once a year. Take a look at your app. If you notice something goes wrong, give us a call. Warranties are usually really, really good. They're 10 to 25 years, depending on the product. And if you've got remote access, the manufacturer will say, this was a problem with this. They'll actually send you an email. And that's pretty spectacular. If you have storage, the same applies for the PV. Clean it once a year. Do an inspection every 2 to 3 years. Make sure that it's properly mounted and properly secured and properly on a resilient structure. Then comes the issues where if there is an outage or an update came through inaccurately, then we usually perform a service call and have to come out to the individual's house and just usually resolve it through a software patch more than anything else, surprisingly. Those are the biggest things that we have to deal with these days.
So then my next question is, what are the initial costs of switching to renewable energy? So I know you showed the calculator, which shows your energy savings, but it doesn't really talk about the cost of the system.
So the cost of the system, the average cost in the United States is, I want to say, about $3 a watt. There's plenty of publications out there that kind of go all over the place. The Virgin Islands has a much higher cost, much smaller market. I would say systems generally average, and it all depends on system size, between $3 and $4 a watt for the solar portion, and that's the solar portion. There are some that are lower, there are some that are higher. But I would say $3 to $4 a watt. I remember we were talking about the system size of 10 panels at 3.25 kW, which would be 3,250 watts times, let's just use the median 350. So it's a healthy investment. A 10 kW system is, a 3.25 kW system is, over $10,000. It's a substantial investment. It's 25 years of energy produced by that system. And that's the way to look at it. It is now a possession that you own, and increases the value of the home, increases the value of the business. It is a fixed piece that reduces the monthly operational overhead. If you add storage in, storage is a different animal, and it runs the gamut. Tesla, on average, I want to say installed is $800–900 a kilowatt hour of storage capacity. Sonnen is double that. Not quite double, 2/3 of that greater again. Sony and some other pieces that do not have as much functionality. There's Schneider systems where you can use LiFePO batteries, which are lithium ion still. But again, these are not all proprietary. These are all systems that take off-the-shelf components, a little bit older technology, have some limiting factors, but are generally, it's still fairly expensive on the storage side. If anybody who geeks out over that stuff saw Battery Day, we're looking at that system cost coming down. Now, yes, it's expensive. In 2010, the average cost per watt installed just on the solar side, like I said, now it's 3 to 4, was $10 a watt. You didn't see a lot of uptake.
And this, I guess we are almost done with our time for today, but I do know that there were a lot of unanswered questions. And I am not sure, maybe we can just try and answer those questions while everyone is still here, but when we post the recording, it will just be the 1 hour.
Can I answer one or two real quick lightning round questions here?
Yeah, I think we can probably run a few minutes over just to make sure that we get everyone's questions in, because for the people who came, we want to make sure that we answer those questions.
And for those who need to jump off right now, please visit our website, and we're looking forward to have you next week and the following week for the next webinar as part of this monthly series or Energy Month series. So thank you for everyone who has to jump. As I said, we're going to stay a little bit longer, but I appreciate everybody's participation today.
Thanks to everyone. I'll be quick through here. I'm going to start from the bottom, and I'll just run through these. Number one, What kind of courses would the average high school student want to pursue to prepare them for careers in solar alternative energy? STEM programs, STEM. And if you are, you say, I hate math, I'm not good at math. You need math. You need to be able to do basic math. You do not have to be a rocket scientist. And if you want to become an electrician, my God, please become an electrician. We need electricians so badly. And with the electrification of everything, you got electric cars, electric homes, smart homes. We need electricians badly. So there, anybody who has an interest, I'm a big fan of the liberal arts, but please definitely work towards STEM. What's the value of installing used solar panels? Installing used solar panels is a complete roll of the dice. The only way to determine a panel's true capability is to do what's called IV string curve tracing. And that is a very expensive piece of machinery that costs about $5,000. I have one. If you want to come buy it, please do, because the only time I use it is on solar farms. And if you buy used solar panels, and I'll give you an example, you buy used solar panels. There was a local judge who we agreed to do the work for. We put them on half of the production. And that creates a difficult proposition. Now, what do? So I don't recommend it. On a smaller system access, training, education, there's a component that could be useful, but on your own home, you wouldn't put used windows in your house unless they were the best quality and you knew that they were good. You wouldn't put a secondhand roof on your house unless you knew it was of the best quality. If you can't ensure the quality of it, it's a roll of the dice. And as long as you know that going in, don't be disappointed if you have poor results. The federal courthouse, St. Thomas, St. Croix, of solar panels, computer software, all of that is going to be rebuilt. The RFP came out, it's going to be revamped. The GSA programs are very high paying, well run, slow as molasses. And what can we learn from these things? What we can learn from these things is the need for STEM programs. We need programmable logic control specialists, guys who can just put together control systems that can access all this data. It's all about sub-metering. It used to be, we all used electricity, and then at the end of the month, we looked at our bill and we said, oh, that's what I used. That's the same as driving a car down the road, but you can only look in the rearview mirror. You want to be able to see what you're doing in real time, whether it's to maintain the assets that you've invested in, all these new electrical assets, and you need to be able to manage those and make sure that they have a long life. So all of those pieces, we're seeing the expansion, and you see the integration of controls, and that's what the government gives you access to. You see that people are integrating them. They're looking at these as necessities, and they're blazing the path forward. Which Caribbean island has the most advanced solar energy systems in place? Jamaica is really aggressive. There's a lot of money involved there. They've really pushed forward. I'd say it's one of the largest economies, so Jamaica, and then maybe Barbados. Barbados has a lot of internal growth in the renewable sector. They have very good companies that have done very large projects. They put out very large RFPs. During the net metering program, part of the American Reinvestment Recovery Act allowed 500 kW of solar, 4 times as much as what it was permissible in the private sector, and not one building was done. So we haven't moved up in that direction. Individual solar systems were first introduced. That is an unknown. This is the estimate of total energy production. It is an unknown. Now, we've run our own in-house numbers, but there's 10 other people out there that don't keep record, plus the number of individual homeowners. We, as consumers, feel that what goes on inside our meter is our business. And so if we want to stay connected to the grid, we have to allow that interconnection. We need to allow that communication back and forth with the utility, unless you just want to get rid of the utility entirely. Those people we don't know. The amount of grid defection is probably in the 4 to 5 megawatt. That's a guess. That's just a wag. So I guess, okay, answered live. All right, that looks like that wraps it up. I appreciate everyone having taking the time out of their day to do this, and enjoyed it. And if anyone has any questions outside of that, my email is probably available. If not, it's Brian with an I at prosolaramerica.com. That's Brian with an I at prosolaramerica.com. Reach out to me if you have a question, if you want some personal information. Obviously, the Green Technology Center out of UVI is a fantastic resource. You should use the resources that you have out of UVI and tell them to start training programs so we can push to get more of those going. And then obviously the Virgin Islands Energy Office, please reach out to them. Between those three pieces, you've got a tremendous amount of resources, more than anywhere else in the Caribbean, in order to get some answers and to see what works best for you, because it's never been a better time to buy solar. I say that every day. So thank you very much.
Thank you, Brian. And thank you for the shout out to CGTC. Please visit our website, cgtc-usvi.com. But just wanted to add one thing to the question of, how can we start working in this field in the VI? You have two answers. The first one, please attend UVI. We have a physics program that is going to give you all the foundation that you need if you want to become an electrical engineer or work, as an engineer or program manager in this renewable energy field. The second one is UVI is working on an associate degree in renewable energy technology. It's not going to be available for at least 2 more years, but we are working on it now. So in 1 year or 2, you will be able to get an associate degree in renewable energy technology on St. Croix. So that's going to be great if you want to start your career, test the waters. But again, you can always join UVI in their physics program or their math program, and that will put you in a great path for success.
Yeah, or their 3-2 engineering program as well.
That's correct. Aya,
Thanks,
you want to
everybody.
close it off?
Take care.
Thank you so much, Brian, for joining us and talking to us about renewable energy systems here in the Virgin Islands and really describing that process. It was very informative and hopefully helpful for our attendees as well. So we have many other events coming up this month, and we hope that you join us for those as well. Feel free to reach out by email if you have any follow-up questions that weren't answered today, and we'll try and get back to you as best as we can. Okay, bye.
Bye, everyone.